Yeah, so I would like to say a little bit about how this came about. So we have QuickCheck around for 10 years now at least in Erlang. And before that, it was already in Haskell. And you see all kind of spawn-offs. And people like to use it. So there's actually, quite some fuss about it and gossip about it. And people do use it and things like that. But then if you start writing Elixir code, and you have this fantastic Erlang tool, how do you use it? And of course you can just use it by typing this semicolon and then the module name and then a dot, and then you can use the functions like that, but it doesn't really look like Elixir code. It looks slightly different. So people asked us, can you not make a kind of Elixir version of it, which is, well, not a one-day job, but of course we can make a link to it, where because Elixir is such a nice language for domain for writing your own languages. So you could make a glue layer on top of it, and that's the glue layer I'm going to present. So it should look like Elixir. But Ulf and I, who made this, we are not Elixir programmers, right? We picked this up, we looked at the documentation on the web, which is perfect, but we only spent little time learning Elixir. So if you think this is not Elixir, you shouldn't do it like this in Elixir, then come to me at the end and tell me how to do it in Elixir. I will also take the course on Saturday, such that I know a little bit of Elixir afterwards. So that will work. But okay, so these are some quotes that we had recently that the OTP team is using QuickCheck for testing their Erlang code. And when a new release comes out, there's this program generator which generates random Erlang programs, and you just run the compiler on it, and surprise, surprise, you normally find a few bugs. So that's always nice to do. They use it for other things as well, so I thought, let's give you some links there. So, because what's the problem? As John said in this talk this morning, some of you probably were there, that you all agree that testing is a good thing. You should test, but it's so boring, right? So people do write tests, but they also very quickly get enough of it. And that's in itself quite understandable. In particular in the Erlang community and in Elixir, I guess it's the same. People are really kind of ambitious, and they like abstractions and programming, and then you have to do something like writing a test case, right? I mean, isn't it much nicer to do a few fault else and maps and things like that than writing a test case? So that's not really happening. So, and I show you a little example here. I want to do this half demo style so that you see how it works. It's much nicer to see how it works than to actually see slides that present something. So first example is we're going to test the lists sequence function in Erlang that does the same as the enum toList and .m. So who of you has never seen Erlang before? Okay, that's good. Who of you has never seen Elixir before? Okay, guys, this is how you write in Elixir. This n.m is a list from n to m. And then there's actually a collection. So you do a toList, so you get a list out of that. And then enum toList is the module enum, or for Erlang notions, the module making a list out of that. So you get the list from n to m. That's the whole idea. And the whole thing is you want now to test that this is the same behavior. So what do? Well, there's this fantastic mix framework, which is really, really nice. So you type mix test, and then you have to test something, so you write your test case. This is how you write your test case. You define a module in Elixir in this way, and you run your unit tests, and this is a test says that this is a test, this is kind of this domain-specific language, this is the name of the test, and then you, in this case, have three things that you check. You check that if you do the Erlang list sequence, this is how you write list sequence, the Erlang list sequence in Elixir, then that's the same as doing the enum toList 1.5 in Elixir. And the same for -10 to 10, and let's take a big number as well, because you never know. And let's do another border case where the number is actually the same number. Okay, so I come up with 3 examples. And if I give a course, I always ask people, come up with another example. And since you're about 50 people here, I would get 50 more examples. And some of them would be almost the same, and some of them would be slightly different, right? Because what is actually so special about those values 1 and 5? I just did like that. It's okay values, but it's not 1, 5 that is important. It's that 1 and 5 are the same on that side, of course. So that's the problem. So any unit test suite has a bit of randomization in it, where you randomly choose a few numbers. Okay? And then there's always the question, do I have enough cases here? How many test cases do I have to write if I want to run this? And that's not so clear either, because many of you will now raise their hand and say, oh, Thomas, you forgot this one. Right? And probably that's true, that I forgot one. So it is always the case that you might forget a certain test case. Okay? So now I want to write a property instead. Instead of writing all those test cases, I want to run a property that says, well, take away this randomization in the actual test case, but do it for all the possible numbers that you can think of. So in order to make that nice, of course you use mix, right? Because mix is already there. So I embedded the whole thing in mix. We have this module simple, where I indeed use the XUnit case, but also this EQC, standing for Elixir QuickCheck XUnit, right? That's what you need to connect the two, unit tests and properties. Instead of test, you write property, you give it a name, and you say do. And this is logic, right? So second high school logic. For all m and n, which are from the domain integer, comma integer, so you take tuples of integers, two arbitrary numbers, and you say, it should better be the case that list sequence is the same as enum2list m.n for all the values m and n. That's how you write Elixir properties. So it looks pretty simple, looks probably not very Elixirish, but we tried our best to make it Elixir, apart from this part, because that's the Erlang one we compare it against. So I can hopefully push now this live demo button, and we jump to the live demo. There we are. That worked. So, you never really know. Okay, so probably if I tell to quit PowerPoint, it would work. That was bad. Hope that, yeah. Lesson learned, don't use PowerPoint. Okay, there we are. Good. So we have a test case somewhere here. Simple. This was a simple test, right, that I showed you. So we can do mix test, and then this is called simple_test.exs, and then it will only run the test in that one, and says, well, there's one test, and I had 0 failures. And this one test was this test case here. Now we jump to this one instead, where I say, okay, let's make a property instead of of 3 separate lines of test cases, and those should be equal all the way down. The reason why I write equals here instead of equals equals is that if it fails, I want to get some nice output. That's all. It is just simply conceptually equals equals. Okay, let's run that one. So now we got a lot of things on the screen. It was, of course, compiling it again. That's the normal mix thing. Then it starts QuickCheck. And then it says exit function clause. So something went wrong. After 4 tests, we got an error. And the error actually then was that we choose the values 1 and -1. And after some shrinking, in other words, trying for smaller values, it said, well, the smallest value I can find for which this goes wrong is 0, -1. And if I do 0, -1, then the left-hand side is actually undefined because it did crash. And the right-hand side, oh sorry, it didn't crash. It gives the empty list, whereas the right-hand side of the equation gives 0, -1. And then it prints, like in testing, it prints a counterexample. It actually shows you the property, and it says, oh, we found a counterexample, and this is the counterexample. But the actual difference is here. So what happens here is that if you do m.n in Elixir, you will get 0, -1 in a list. Whereas if you do 0, -1 in Erlang, you will get the empty list. Yeah? So they are not the same. And this property shows it, And you would have, all of you would have written this particular test case, of course, as well, but there might be people that forget certain test cases. So this is how that works. But it's compatible in the sense that this is what you would normally get out of a mixed test case and a failing test case. And you also see here, I haven't fixed everything, so it should say there's one property that failed instead of one test, but that's it. Okay, so that was nice. And I'm a bit hesitant to jump back to my slides, but I will try anyway. I'll probably, no, let's do that. Let's be brave. So there we are. So this was the property for comparing things. So these things that you have here on the right, inside the for all, you say for all, and then you give some variables, which you bind with some domains, so the domain of which you pick those variables. Those things are called generators in QuickCheck language. So they generate an arbitrary integer value, and that's what I used. And then we saw that the thing was actually crashing and had a counterexample. So that was one example of how QuickCheck can be used. A second example would be the newly added function enum usort. Who has seen it already? Only one. When did you add it? There you go. Okay. So I picked this just to have a nice example, because everyone probably has a feeling of what usort would do. Usort takes a list of values or collection, right? And it will, of course, sort that. But if there are duplicates, you have to throw away the duplicates. Yeah? So it's a sorting function, but there should not be any duplicates after sorting. It's a handy utility function to have. So now the question then is, okay, what kind of property would you come up with? And there's a scala of properties that you can think of. The list should be sorted after this. That's a good property, right? The numbers or the things in there should only occur there once. That's also a property. So you can think of all these kind of properties, and there's always a bit tricky. What property should we actually take? Because there's so many that you can take. And there are some guidance, and you can do some certain things. But you want to pick a certain property and say, okay, let's test this. And normally, that's the intellectual kind of difficulty to come up with those properties. That's really hard. Usort is relatively simple to come up with properties, but what should my database do here? That's hard to write properties. So I advise always take something extremely simple of which you are absolutely sure that it holds, and use that as a starting point. So what would absolutely certainly hold if I use usort? Well, I think that if you have a list and you sort it, even if you do usort, the elements that you have in the original list should also be in the sorted list. It would be strange if you throw away elements, right? Okay, the duplicates you throw away, but each element should more or less be in that function. So I make my own generator. In QuickCheck, you can make your own generator very easily. You do that with a private definition of the numbers. And a number is either an integer or a real. That's what we do. So you take either an integer or a real. And reals is floating point numbers. For historical reasons, we call that real. And then we have this property here, and it says usort does not remove elements, in the sense that the elements are completely gone. So we take an L, which is a list of numbers, which is non-empty, because going to sort the empty list is certainly possible, but then we can't say, and now take an element and make sure that it's really in there. So we take a non-empty list of numbers, and these are all standard QuickCheck generators, so you don't have to write any code for that. And then you say for all the x in this list that you generate, it should better be the case that, oh sorry, I have to usort this, of course, that if I usort the list, then this x should still be in the list. So I don't know where list comes from. I will show you the real code later on. But I use the enum member function to test that it's actually there. So this should better be true. So we switch back. Slide. So if there are questions while the screen is black, you can always interrupt and ask those questions. So let's look at the real code, because there was clearly something had gone wrong there. But this is the real code. No, this is not. This is the real code. So I define my number generator, and then I say for all non-empty lists of numbers, I usort the list with the enum library, and then I do member x, and this member function is defined down here. It is really member question mark from enum list and x, but if in the very unlikely case that this is not true, then you want to print the list that is not kind of the element you lose from the list, right? So that's why I have this when fail here. That's also a QuickCheck primitive saying, okay, if things go wrong, please do this, and this, that is printing some stuff. And I really learned some Elixir here, right? I can actually do this without tilde p and /n and things like that. So that's Elixir code for printing things, IO format. Okay, so this should better be true. Let's run the tests. And you will see it is. At least, if you're lucky. So we run 100 tests, and we get 0 failures. That's good. Let's do that once more. And a few more times. Oh, once more. What happened now? So after 70 tests here, after 70 tests, it failed. And I did 100 before. So it actually needed 170 tests. It didn't take much time though, right? 2 times return. But then it found something which it says this is not good. What happened? You took this list, -1.8, -17, -17.0, and then the number -17, and it did some U sorting, and it said it didn't occur. Then you see some shrinking, and it says, well, even if I start with the -17, -17.0, if I pick the -17.0 and then look, is that still in the list? It's not in the list anymore, because you throw it away when you were U sorting. Okay? So even simple properties can reveal errors or strange things in your API. And what I would say here, what's actually wrong here? Yo, Jose, what's wrong? My property, right?
So we have like 2 comparison operators in Erlang.
Yes.
So, and it depends which implementation you choose to use. And you're going to see that reflected in the result in the property.
In your API, you would probably like to say which operator you use, because then you can compare with the same operator as where you do your U sorting. And then the thing should actually go through. But here you do not have a choice. You fixed, in the member function, you actually fixed it to be one of the 2 operators, whereas in the usort function, which you didn't write because that's a list usort, you choose the other one.
Yeah, that's a good point.
Yeah? So and that's where things mixed up in this example. So a simple property, a not very efficient property because we used 170 tests to find it, but it shows you that something is slightly wrong in your design of your API. And that's the message that I want to give you, that things can actually go wrong slightly. Irritating. But then we did now and then run 100 tests, and then actually you get, okay, it's successful, and we did have 100 dots here, but then you wonder, okay, what did I actually test here, right? I run 100 tests, but what did I test? And in particular, I mean, not the developer so much, but managers can get a bit upset if they only see dots instead of test cases, right? They want to have reports and things like that. So you probably want to spit out something like that as well. So that's what we did, cater for as well. So you can collect your test cases. So you can write something like collect, and then you can give it a name like the lists or something like that, the lists that I use, and then you can give it L. These are the sorted lists. And you want to do that in the following member function. So I thought this is relatively Elixir-ish code. It looks Elixir-ish to me, at least, so probably too many columns, but works. So let's run that. And then you see actually the result of all the lists that you are testing. So that's nice. It gives you some confidence that you actually tested something more than just the list of one element. So you can do that kind of tricks. You can also, if you want to, collect a little bit more. Now I only collected the the L, but I can also say, well, what X did you actually look for, right? And then you could write it like that. And again, that would then, oh yes, and of course you could still have the failing case. In this case, the failing case is minus 2.0, minus 2, and then you get that. But sometimes it just works. No, sometimes it really works, and you get your output. Yep. And these are the X's, right, here, that I choose, and these are the lists that I generate. So I get both as statistical output from my test cases. And if you want them combined, you just put them in a tuple and you see them combined. So that's QuickCheck in a nutshell. That's properties and generators for the data. But this is nice, right? U-sort functions. Oh, we can test U-sort function. Who will ever make a mistake in the U-sort function? So that's relatively useless. But real software has state. And as John already told us this morning, then you do have to test stateful systems. How does that work? Now, let's have a look at that then. I have to jump back to my slides. And show you a little example of how we test stateful systems with Elixir, and then how you find concurrency bugs in those. So software has certain properties, that's what we now say, right? And that there are things that should always hold, a little bit like requirements, you could say. And a test case is one verification that a certain property holds. So you get only one proof. If you write a complete requirement, you get it for all possible input data. But in real software, properties are more complex than just saying, well, the element should be in the list. Real software has state, and therefore properties have to be stateful. And instead of writing, just generating data, you now have to generate a sequence of calls. So you basically have to generate your whole test case. That's what you're going to do. And then you have to shrink to the minimum failing test case, because otherwise you get too much rubbish, and it takes you time to analyze your test case, and you really want to see the minimum test case where something goes wrong. That's if you work for yourself. If you work for a company and you test for them, you give them this really big test case and you say, this is going to take me a week before I find out what, and then you go to the beach and then you come back and say, well, this is the actual minimum test case, right? So that's in perspective. Do you know what this is? Sweden is full of it. Every shop has one. So you take a ticket and you are in line, but you don't have to really queue. You can just be in the shop and do as if you're not there. But you have your ticket. As soon as the display says it's your turn, you run forward, you put your ticket there, and you're helped, right? So it's called a ticket dispenser. So a ticket dispenser has two operations. You take a ticket, and, this was nice. And reset. Reset means you put in a new roll of those tickets. Yeah? So assume you do a fancy electronic version of this ticket dispenser. That would be nice. A fancy electronic version where people can actually push a button and then they get this number back. So then you have to write some software, and you have this API where you can take and do a reset. So how would a test case look like in Elixir? Well, a test case in Elixir would look like something like this, right? You start your ticket, you have your test ticket dispenser, you start your ticket dispenser, and I write sut here because, and this is nice in Elixir, you have aliasing. So you can say, well, I have this old Erlang version, which is called the ticket dispenser, and that's my sut. Or you say, no, let's do my new ticket dispenser, which is the super good Elixir one, and write sut there. So you can test both, and you can see that both are actually doing the right thing for this test case. So when you do start, you should get back OK, disp, that's the dispenser. You take a ticket, and it should return a 1. You take another one, it should return a 2. You take another one, it should return a 3. You haven't tested reset yet. This works fine. Let's test the reset. You reset it, and you take another ticket, you get a 1. Perfect. It works. Stop, done, test case, ready. I tested this, and actually it just went through with that one. But let's do that here for real now. It's always nice if you can run tests in a live session. So we go to the Dispenser Test here. Oh, now I have Erlang as the first one here. So we test Erlang first. Dispenser Test, it was called. So the Erlang version works, super. So let's test the Elixir version. And even the Elixir version work. So they are perfectly okay. Software is good, we can ship it. But, well, then you might say, well, how would the property look like? Right? How would the property for such a system look like? Well, you have to generate, basically, this test case. But not only one take, but probably 10 takes. And probably a take, and 2 resets after each other. Or 3 resets, and then see that it still works. That you didn't leak memory or something like that. So even if it is very simple software and only a few lines of code, you might want to have a few more tests than just this, but you really don't want to write more tests, right? Because you will always get the question, why did you write this test and not something else? And did you have enough tests and all that stuff? So you would rather specify what the ticket dispenser should do. So that's what we do. We specify that, and we make a state machine model that says, this is what your ticket dispenser does. And your property will be a generator for commands like take and reset. So let's have a look at that code and jump to the property straight away. So the property would say, I generate commands which are defined by the behavior in this module. I start my subject on the test. I run I run my command sequence because I made the command sequence. I run the command sequence. Technicality, you get a pit here. Your sequence doesn't know what process you're actually running, so you provide that to this test sequence by substitution, basically. Say substitute the pit I got from my start into the sequence, and then you stop it, and then this pretty command gives again a nice printing for the whole system. So this is how that works. And again, it starts looking more Erlang-ish, but it's still Elixir code, right? So what we do then is we have for each argument, each command in my API, I define a number of callback functions that tell me what is the logic of the system. One of the things I need to have is an initial state, and my initial state here is 0, because I think that's a good initial state to have. And when I take my first ticket, I increase that and I give myself a 1. So in the take function, I have randomly generated arguments, but I actually substitute just the pit that I get. I take it by calling the sut take. My next state function increases the state by 1, and my post condition says, well, if I start in this state and I then do a take, then the result that I get from the system should be state plus 1. So if I do a take, I get plus 1 back. This is the logic for take. This is pretty simple. The logic for reset is, well, similar. You get your command generator, which is random arguments for your command, but it's not, you have to give the pit. You reset the system. You can, whenever you do the next state function, you're back at 0 again, right? That's the 0 over there. Here's a 0, saying, well, if you reset, you're at 0 again. And then you have this post condition say, well, if you do a reset, the result should better be 0. And then we have seen all the code apart from the weights. The weights can give you kind of balancing. I want to do more takes than resets, but I commented out that at the moment. This is also interesting. This morning I had this fantastic talk from Jose telling me that I should have used agents. So I did write an agent version while he was talking. But let's test the Erlang version first, right? So there we go. Dispenser EQC. Okay, the Erlang version actually is fine. So that's my model. That's my legacy software. I want to make something which does the same thing as my Erlang function. Okay, so I start hacking, and I'm not a really good programmer in Elixir, but I made a gen server solution here. A bit tricky, probably. But let's run that. So now I'm running the Elixir code, my Elixir generic server. And kaboom, things go wrong. Not completely surprising. So I get a long sequence, and then I get, okay, if I do a take, yes, I should stay here. If I do a take, I get a 1. That's good. If I then do a reset, I get a 2. That's not good. I expected a 0. Okay, so I made a mistake somewhere. Why did we not find this mistake in our unit test? Do you remember the unit test? Shall I show you the unit test?
Too many ticks.
No, it's more subtle than that, actually. I never ever check the result. And that is not only me that does that kind of things. Okay? Okay, so okay, fine. That didn't really work. You got a 2 back. But if you then shrink, you actually say, well, no. If you do a reset, you get a 1 back. But I expected a 0, right? And 1 is not 0. It really is not. So something went wrong here. But the nice thing is, because of the shrinking, we have 2 examples where it goes wrong. This one and that one. So it does very little sense to say, oh, reset in my implementation always returns 2. No, it can also return 1. Yeah? So you have to go into your code and see what you actually did wrong. Or, and this is a very good trick, they do that many times, you just remove the post condition of this command, right? And then you don't test it anymore, and therefore it is correct. So you just do it like this. That is an excellent trick. I mean, who cares what reset is returning? No one cares what reset is returning. Okay? So we test this, and oh wonder, it works. Okay? So now we know actually how to test this and that it actually works. And now the agent implementation. So if you look at the code for this dispenser, I will show you my Elixir code. Don't tell anyone how I write Elixir, but this is my gen server implementation. I will make it slightly larger. So in the gen server implementation, it's really like, okay, you start, you do gen server call, and then you do a stop, a take, and then you do a reset, and then in the end, you have all those handle calls and handle things. That's not really nice. Instead, you should have done it like this. The agent. This is all the code there is, right? Beautiful. So the only thing I don't really like, and that's why I introduced an error here, is in the take. But look at this. I return a 0 here, just to be sure that reset will return 0. It's probably not the most beautiful code, but okay, this actually is compatible with the Erlang version then. So let's test that one as well. So we go here, and then we just comment out this one. And there must be a better way of doing this, but fine. So we test this one. Okay, fine. So all the 3 implementations now pass. Right? We have 3 nice implementations, they all pass. But, you know, and now I have to jump back to my slides. We didn't really test our implementation, did we? We just did some unit testing. And we never ever tested this for concurrency errors. And if you read a book about software engineering from Somerville or whatever, then they say, no, but concurrency errors, you do not test concurrency errors with unit testing. No. You do that in a different phase in testing, right? Unit testing is for something else. So let's jump through this rather quickly. So what if there are 2 customers? And your system is not as robust as this paper roll. So 2 customers come in, you have just reset your system, there's a blank tape in there. 2 customers come in, one takes 2 tickets and the other one takes 1 ticket. Some people take 2 tickets. It's a bit stupid to do it directly after each other, but if you want to go shopping in between, you might come back and take another ticket. But anyway, you take 2 tickets and the other one is taking 1 ticket in between. How do you write a unit test for this? We're talking a simple program, right? It's only 3 lines of code basically and then some defs around it. So it's a really simple program, it's concurrent because different people can take a ticket at the same time. How do you write a unit test for this? It is slightly difficult, right? It's because you have this concurrency, you can have different options. So you can have one taking 2 tickets and then the other one coming afterward, or they merge nicely, or one is going in front of the other and takes 2 tickets and then the other one can take 2. So there are several possibilities, like this one. The first one takes 2 tickets, the last one takes the other one. Or this one, 1, 3, 2. That's a possibility. It might be that you indeed get this outcome from running the software. It might even be that that one is really fast and takes the first one, and then you have 2, 3 there. So you have a number of possible correct outcomes. Right? How do you write your unit tests? Well, there's one thing you can say. You can say, well, if I see that one, 1, 1, 2, then something is really fishy, isn't it? 2 people have number 1. It's enough for fight. So that's really, really bad. So this is wrong. The red one is wrong. But all the other ones are good examples. So you could actually start, this is fantastic, you have Erlang, you spawn 2 processes, you let one process do the things, you let the other process do the things, you collect all the results, you start computing, say, is this actually possible? Yeah, that might be possible. You just list all the possibilities and then you compare. And so that would work for that example, but if it is slightly larger, it doesn't work anymore because it's too much. The number of possibilities you have here of what is good behavior and what is bad behavior is too much to actually just list and not make a mistake in that listing. Right? So you have a problem. The problem is that there are 30 possibilities of correct outcomes. You might be able to list them, and then your manager comes to you, yeah, but what if you do the reset here and the take there, and you can start all over again, right? And that's not very nice. So, writing unit tests for concurrency events, that's just headache, right? It's not possible. People don't do that because people are kind of naturally averse against headaches. So you don't want to do this. You want software to do it for you. Because a computer can count and computers don't get headaches, so let them do the work. Okay, there we go. This might be very complex, right? Now I have to write a model that actually caters for this parallelism. How much work would that be? Well, this was my dispenser. Which one do we want to test first? Probably this ticket agent here, because that's how you really should write your software. So what do I have to do to make this a parallel model? Well, I have to say, instead of generating commands, I have to generate parallel commands, right? Because I want to do things in parallel. And if I do that, I better run them in parallel as well. I add the word parallel there. I save it, and I run my tests. And now I have my parallel testing. And it actually finds an error in software which we have tested before and was error-free. Right? So what it says here, after some shrinking, forget about the long thing above, it says, look, if I do nothing in my sequential part, because it has a sequential sequence to come to a kind of interesting state and then does the parallelization, if I come to my parallelization and I do 2 takes at the same time, there is a possibility that I get a 1 back from both of them. And that is not good. And by the way, this is a minimum test case. You can actually understand that this is not good. You don't have to do lots of debugging here. And this is all completely automatic, and it says no possible interleaving. Why does it know that? Well, it knows what the model should be. The model should be that you get 1, 2, 3, 4, etc. It cannot in any way relate those events to what should happen in the model. So it can just say, well, this is not possible. You did something very weird in your implementation. Okay? So that's what it does. So you find your concurrency errors very cheaply. We didn't have to do much, but now we have to fix it because I only have 10 minutes left and you have to have questions. So let's look at the dispenser agent. This was the code I actually was running. And you see, right, this is, oh my God, back to university. People should not write code like this, right? No. There must be a function, get and update at the same time. It must be atomic, right? And of course there is. Jose is, you just make those kind of things, right? So you do get and update here, right? And then you have to slightly change your type, because now it has to return two things, right? The thing you return, and then you update the state. You can just throw away this ugly code here. And it's even shorter. It's beautiful. So, ta-da! 100 tests. 100, and I got rid of my concurrency error. That's it. It works. I left some time for questions.
So, I assume you're still like actively working on it, because I noticed some of the early output is still in Erlang terms.
Yeah. I should have switched that off, but then that's relatively easy to switch that off. It's completely uninteresting output. You are referring to this kind of output. You don't want to see this, right? That's the thing. Yeah, you can switch that off, that you don't see that, but I was lazy and didn't do that. But in the end, what you really want to see is this pretty printed output, where you see what you're actually doing in your test case, right? And that's, yeah.
Well, I mean, that is still in the Erlang terms. The Elixir terms would be, it would be coded, it would be documented.
Ah, right. Okay, so I have to, thank you. I have to change my pretty printer to actually print a dot and instead.
Do you want to actually use inspector like output so that the
Probably, yes. Probably would work. Yeah. Thank you for the tip. That would in the output make a difference. Yes.
How much more complicated to compare implementations one with each other?
If you want to, so the question is, how much more complicated would it be to check two implementations one against each other in writing code? So what we do now is we make a model of a system, compare it to one, and then use the same model to compare it to the other. You could try to run the code on this one and then run the code on that one. Now, if the code doesn't interfere, it might be relatively easy. If it interferes, you have to still generate your test case. Yeah, you have to do a take, reset, take. You run it there, you look what answers you get, and then you run it in the other one. Now, the tricky is that that works nice for this example. But in real code, it doesn't sometimes makes sense to call a certain API function in a certain state. You say, well, for example, if the roll is not longer than 24 tickets, it doesn't make sense to take a 25th ticket. So you have to put that in your test case generator, that it doesn't make sense to take 25 tickets. So you're going to write those lines of code. So you're building your model in order to steer your test case generation. The only thing you take away is the post condition. And I already took away the post condition for reset. If you also take away the post condition for take, then of course you would have the test motor that would steer the two, and then you could compare. But then I think it's equally easy to just add the post condition, and you're done. So it's not more easy to do that. Although you would intuitively say, oh, but I have my model already. So why not use that?
No, my question was more about like what would the test generation code look like if I were to do this?
Yeah, you still would have all the code in there, apart from the post conditions, in order to hit the stage you really want to hit. Yeah.
Is this open source?
This project is not open source. This is a commercial tool.
Will we have a license for open source projects?
There is a license for open source projects, so everyone can go to QuickCheck CI. And at the moment, we have not Elixir installed, so you have to install Elixir as part of your test. But we will put Elixir on it, of course, and then you will be able to run your Elixir test there. Yes. But that's only for open source projects on GitHub.
Has anyone used this over JInterface to use QuickCheck to generate, to test the JInterface, like the Java side of the database?
Right, I have no time, but the question is, does anyone do sensible stuff like talk to Java? I have a Java implementation of this ticket dispenser, and I can equally well test it. So and that's very little work. I use the same model and the same things, only have this connector to make it marshal to Java and back again. So it's relatively simple to do that, yes.
What would you do, how would you test if the ticket dispenser, say, had a constraint where
So the question is, how would you do if you have an automatic reset after, say, an hour? And there's no API function for it, but it's built in the software, and you can't control it. So it's a software which is uncontrollable. And there's two answers to that. First answer is, stupid, don't write that code, right? But you don't always are in control. For example, when we did TCP/IP testing, if in the TCP module, you can have lots of things that go wrong, which you can't control. And then it is fault recovery, so it will show. So what you have to do is either probe. So you really kind of take control over time. You do fast forward in time or something like that. If you can't even do that, then you have to sit there and wait for an hour. Sorry. Then you do a sleep, wait 1 hour, and you go for a long coffee break. And you have one test, and then 24 in a day, right? And it's in that situation, I would say, you do something wrong. You should not write that kind of software. You should at least be able to have that as a configurable timer. Say, well, okay, normally an hour, but now a second. And then we just wait a second. And then the trick is always, in that kind of things, did I wait sufficiently long, right? Because what you really would like to test is around that second. But you don't really have a good specification of what should happen around that second. So you can either go over the deadline and you know it's reset, or you could be just inside, before the deadline, and then you do something like that. So, and that depends a bit on the application area, what you really would like to test out of that specific situation. If you call, if this timing thing is calling some other function that you can control, so not necessarily that you have to call it, but the timer function is calling your C library to see what the time is, then you could actually mock that C library and say, okay, I just say this is my time. And then you could steer it again. Yep.
Yeah, when you put in the modifications to make it do the parallel testing, it did find an error.
Yes.
But there was sort of like a here a miracle occurs kind of thing aspect to that, because you don't know what it did and what other errors you have found.
Yes, yes. Sorry. So the question is, this looks like magic. How does it work? So you're right, and I didn't show the slides because I was a bit out of time. But since this is the last question anyway, we have this model where you have resets and takes, and you update the state of that model. So the model says basically what the system should do. And there's a link between the action you do and the state, the output you expect. So now if you do it in parallel, you just do things in a slightly different way. So the trick now is to find a path through the actions that you can explain by unfolding the path such that it is corresponding to a model action. Yeah? So there's some computation going on there saying, well, okay, I have this strange range of events. Let's order them in all possible ways and see if one of those possible ways is actually a valid way of running through the model. So that's, you sequentialize your parallel actions and say, is there sequentialization? Then it must be okay. If not, something's wrong.
Okay, makes sense.
Okay. One last question? No? Okay, thank you.